This video is sponsored by PCBWay. Hello everyone, today I've got a very special video for you. As you may know, I've made many VR devices in the past, like VR headsets, augmented reality devices, and even my own Slime VR trackers. Today I would like to show you my brand new Persephone VR controllers. Persephone VR controllers are fully SteamVR compatible and are capable of real 6 degrees of freedom movement. This means you can freely move around your room and the controllers will be tracked along with you. Today I would like to show you how I made them and how you can make them as well. PCBWay, the sponsor of this video, was super kind and sent me all of the boards that I will need for this project. The package arrived at my home in under 5 days, which is super impressive since it came all of the way from China to Europe. Of course, everything was safely packaged in nice cardboard box. This board right here is my brand new design. It's basically a very small Raspberry Pi Pico with built-in traces for the gyroscope and couple of extra things. In this video, however, I will use this board as a small wireless receiver for my brand new Persephone controllers. As you can see, the build quality is very professional. All of the traces are easily visible and blue solder mask give it a nice professional look. The board itself is not super complex. It's basically a very small Raspberry Pi with the gyroscope board attached to the side of it. So now let's go ahead and assemble the board. Of course I will be using a lot of solder flags, which will make the soldering a lot easier. And now I will coat all of the pins with solder. This will make the hotter soldering way easier. As you can see, all of the pins are now completely covered with solder. So now let's go ahead and solder all of the Raspberry Pi components. Of course I did all of the soldering off screen, since it requires quite a lot of precision. After soldering, I carefully clean all of the flags from the board using IPA alcohol and toothbrush. After cleaning, the board is pretty much finished. I've left the gyroscope pads unsoldered, since this time I will use this board only as receiver. Of course, to make it work, I will also need this wireless module, but it seems I will have to clean it up first. Okay, so I've cleaned up the module and I will now connect it to the main receiver board. I will use those pins right here and then I will connect it to the pins on my board. After a short while, both boards are now connected to each other. Of course this thing wouldn't be complete without some sort of plastic case. I've designed a simple plastic housing which will fit both boards inside. As you can see, it's a pretty tight fit, but there is just enough room for everything. Of course, I've also made a matching top cover with my logo on it. Both parts are designed to perfectly fit with each other, and the whole thing uses 2 self-tapping screws to close everything up. The whole thing is pretty basic, but it will get the job done. So after all of this, I've connected the receiver to my PC and I'm now ready to proceed with next steps. So now let's assemble the main controller boards. The controller uses 2 separate PCBs, the big one for the buttons and smaller one for the rest of the electronics. The main PCB has all of the traces for the microcontroller, gyroscope, battery management and wireless module. First let's assemble the button board. This one is actually super easy to do. Of course I will use a lot of flags, which will help greatly with soldering. And now I will apply some solder, but only for one of the button pins, since you can't solder the buttons with hot air. Of course I will use tact switches for all of my buttons. And now I will carefully solder the button to the single pin with solder in it. Of course I will do the same for the other buttons as well. With all of the buttons in place, I've applied solder to all of the remaining pins. Now we can solder the joystick. I will be using the same joystick that you can find in PlayStation 4 controllers. I plan to switch to the Nintendo Switch joysticks sometime in the future, since those are way smaller. With the joystick in place, I can now apply the solder. And now the joystick is fully soldered. The only parts left to solder are the ribbon cable connector and those small SMD components right here. I soldered the SMD components off screen and prepared the board for cleaning, but it seems I will have to skip the ribbon cable connector. So now I will remove all of the flags using my spare toothbrush. This will make the board look way better. Okay, so the button board is pretty much ready now, with the exception of the ribbon cable connector. So now let's assemble the main controller board. This one requires a bit more soldering. Just like before, I cover whole board with flags. And now I cover all of the pins with solder, since I can use hotter this time. And now I will solder all of the battery management components to my freshly prepared board. The LEDs got slightly damaged in the process, but those should work pretty much fine. And now I will solder the rest of the components. I will transfer those from my previous board. After soldering, it's now time for the final cleanup. And here is the complete main controller board. I've left the ribbon connectors empty, since I don't have any connectors at home right now. So I will have to connect both boards together using short Kynar cables. It's a pretty annoying task, but I just can't help it. With all of that done, let's assemble the controller. I will start with the bottom housing, which was printed in black PLA. The first thing you want to do is install the trigger button. You will also need a piece of filament which will act as a simple hinge. First, push the trigger button inside the plastic housing. After that, slide the filament piece inside those holes on the sides. It should go all the way to the other end. And now you will need to make the filament piece slightly shorter. And now simply melt both ends with your spare soldering iron. This will prevent the filament piece from coming out of the assembly. The trigger button should move only slightly. Also make sure that it's not getting stuck inside the plastic housing. It should be fairly loose. And now I will install the tact switch button. I've already soldered all of the wires to make things way easier. You will also need this small plastic piece, which will work as an adapter. First, I will put the tact switchboard on top of the plastic adapter, and then I will melt those plastic pins with my soldering iron to keep it secured in place. And now the button is pretty much finished and can be safely installed inside the plastic housing. The tact switch button goes directly on top of the trigger. After that, you use two self-tapping screws to secure the button in correct position. Make sure you can push the trigger inside and can hear the tact switch clicking. Okay, so now let's install the grip button. This one is very similar to the trigger button, but this one goes into the handle part, as it will be used to simulate the gripping in VR. Of course, for the grip button, I've used two self-tapping screws as well, which will hold everything in place and prevent the tact switch from falling out. This part right here is the top housing. It will hold all of the PCBs in place and close up whole assembly. I've also got this small battery, which will be used to power my controller. I've already prepared all of the cables, which will connect directly to the controller. The battery itself fits snugly inside this groove right here. It doesn't have a super high capacity, but it will work just fine. I will also use a bit of hot glue to keep it in place. After using hot glue, there is absolutely zero chance of the battery falling out or even moving. So now let's grab the controller boards and connect them with the battery. For that I will be using those pins right here. Okay, so I've connected everything together and I can now install the board in its correct position. However, it seems that the battery wires are getting in the way, so I will have to solder them again from the other side. Okay, so I fixed that slight mistake and now everything should fit perfectly. As you can see, there is just enough space for the electronics. So now let's connect the buttons to the main board. This step is pretty easy, since I made the wires quite long. I will do the grip button first, which connects to the pins right here. With the grip button connected, I can now connect the trigger button. This one connects to those pins right here. And now both buttons are properly connected. And now this is the part where we closed both pieces together. This one is pretty tricky, since I have to make sure that nothing falls out when I close up both pieces. After closing both pieces of the housing, I will use a couple of self-tapping screws to completely seal all of the plastic parts. It looks pretty good so far, but there are still a couple of things that we need to do. First, I will have to apply some of that hot glue under the button board so that it stays in place and doesn't rotate. But before I do that, I have to connect the tracking LED, since it won't be accessible later on. Of course, this build also requires one regular ping pong ball. I've made a small hole on the bottom, which perfectly fits the tracking LED. And now I can solder the tracking LED to the controller board. First, I put the wires through the tunnel at front without getting the LED too close to the plastic piece. The LED should be placed more or less in the middle of the ping pong ball. And now I put the ping pong on top of it. Of course you will need some hot glue to keep the ping pong in place. Now that the ping pong is installed, I can safely solder the wires to the button board. The LED connects to those pins right here. So now you can turn on the controller and check if the lights turn on. If it starts glowing red, it means that the controller is now working. So I've secured the button board in place using hot glue and I can now install the button cover. This part is fairly simple. It's basically a huge plastic ring that goes directly on top of the buttons. Of course you will need actual buttons as well. The buttons simply slide into those holes right here. When you have all of the buttons in place, you can very carefully connect both pieces. Make sure to do this upside down so that the plastic buttons won't fall out. Also make sure that all of the buttons are clicking. And now I will close everything up using my spare soldering iron. And just like that, the controller is now finished. All of the buttons are working perfectly fine and it's very comfortable to hold it in hand. The joystick is slightly too big for me, so in the future I will replace it for a smaller one. For the positional tracking, you will need two PlayStation Move cameras. I recorded the calibration part with regular PS Move cameras, but since then I've converted them to this stereoscopic DiY Remix base station. It's basically a custom housing mod, which made things slightly easier for me. For the tracking calibration, you will need a piece of paper with this wacky thing on it. I've used a regular laser printer to print it out in A4 format. When you place the calibration mat on your desk, make sure that all of the cameras see it properly. Now you can start the PS Move service EX and check if it recognizes all of the cameras. Now check if all of the cameras can see the calibration mat. And now choose the tracking device and click on Calibrate Tracker Poses. Now you can turn on the controller and wait a second for the LED to turn on. Make sure you have properly calibrated the tracking colors. And now you are ready to start the calibration. First select the proper paper format, check if all of the cameras can see the tracking device, and finally start the calibration. First you will have to put the controller in this spot right here. When you have it in correct position, click Continue on your PC. And now do the same for the other calibration points. When done correctly, you should now see something like this. What you see on your PC should represent your physical setup. And now you can test if the tracking is working properly. In order for this to work, you will also need the DiY driver. I've already did all of the setup and put my left side monitor as the headset viewport. And now it's time to start the SteamVR. As you can see, my monitor is now working as a VR headset. I don't have my controller turned on yet, so all of the controller icons are grayed out. So now let's turn on the controller and check if it's working properly. As you can see, it connected to my PC and I can now see the controller icon. It also appeared in the VR view. I don't have the PS Move service turned on yet, so there is only rotation data from the gyroscope. So now let's start the PS Move service. As you can see, the controller is now visible in VR and the positional tracking is now working. It's a bit glitchy since I'm way too close to the cameras. And here you can see it from my point of view. As you can see, the VR hand is moving along with the controller. And that's basically all for today. Thanks for watching everyone and hope to see you in the next video. And as always, huge thanks to my patrons and PCBWay for sponsoring this video. See you later and goodbye.